and welcome back to the final episode of RISC-V instruction encoding. So that was it. We have covered all 6 types of instructions that we will encounter in RV32 version that covers all the integer operations. There may be different ones for different extension, but this is the base that is good enough to allow us to compile any C program to it. That's quite amazing, isn't it? The principles that we have seen here are that we have sacrificed some of the perhaps understandability of how the immediates are being formed for ease of hardware design. So things are always placed in the same place. Registers are always in the same place, such that processor hardware has an easier time finding them. Similarly, all the immediates are aligned in a way that the processor will generally find them in the same place. And that'll make the design easier and make the hardware run faster. And that's worth any added complexity that we have to do in remembering how these instructions work. There have been quite a few changes to RISC-V ISA and its specification. In the past 10 years, since the project started, we have seen numerous versions. But there is something that is very exciting, that the base and several of the extensions of the RISC-V ISA have been ratified. So that means that the community has accepted them and they've been frozen forever. They will not change. There's one little catch. There is a lot of stuff out there that is based on draft specification of RISC-V, including the Patterson and Hennessy textbook. So some of the things that we will find in the textbook are not exactly the same how they are today. The textbook is about 3 years old, and things have changed since, but they're not going to be changing going forward. The differences are really minor. These are some of the encodings have changed, and some of the naming has changed, but in general the principles stay the same. So what we have here are all the base instructions that we have in RISC-V RV32I ISA. And that's it. We haven't covered 3 instructions that are useful for environment calls and generally operating system support and running multiple threads. We don't need that. For now, we can run any C program with the set of instructions that we have for now. And that's quite exciting. That will enable us to run through our stack of building computing systems, starting from C down to assembly language, machine language, and we have really now understood the ISA. Now, after we understand how we compile, assemble, link, and load, we're going to get into actually building the hardware that can execute all of this. Stay tuned and see you soon.